The northern lights, or Aurora Borealis, were visible to the naked eye in different parts of the world on October 11th. England, Russia, the USA, and even Ladakh saw the sky turn blue, red, and green. In today's episode, we discuss what caused these northern lights with an astronomer and former professor at the Indian Institute of Astrophysics, R.C. Kapoor. Earlier, NASA had alerted regarding the possibility of a solar storm driven by heightened solar activity such as solar flares. This is said to potentially affect satellite communications, GPS accuracy, and even power grids. Indian scientists are monitoring it, and experts at the Indian Space Research Organization said they have informed Indian satellite operators to take all precautions. Thank you so much, sir, for joining us firstly. And before we delve completely into what's the NASA's warning and what does it mean, first, can you just help us understand what do we even mean by solar flare, solar storm?
See, as we know, the sun is a average star, and its surface temperature is about 6,000 degrees, and the temperature at the center is 1.5 crore degrees centigrade. It's a very hot body of hot ionized gases, mostly hydrogen, and say. 73 or 74% hydrogen, and then 23 or little more percent helium, and then some other elements. Now, nuclear reactions are going on in the center of the sun, and the energy released in the conversion of mass finds its way out, and then we see how the sun as a very hot and intensely bright body from where we receive the sunlight and the whole solar system. And now, the sun is not just a hot body of hot gases. There is magnetic field also, and then the sun rotates also on its axis. So, because of the magnetic field and the ionized state of the matter, gaseous matter, there are some interactions going on, and then there is a certain cycle gets established about the various kind of processes on the sun. That cycle is called solar cycle. It's an 11-year cycle, and right now we are going through the peak of its current cycle of solar activity. We call it cycle 25, and in this, at present, a quite large number of spots are seen on the surface of the sun. And presently, there is a huge spot on the surface of the sun, and then it's right towards us. As we see, it's almost close to the center of the body of the sun, as you see through a proper filter. Possibly naked eye also it can be seen, but there has been these dark spots are also very hot places compared to the rest of the surface. Their temperature is about 2000 degrees less, so there is lesser light in terms of intensity that is coming to us, so that's why they appear to be black. But in these spots there is a very high and strong magnetic field. So in strong magnetic field, when the charged particles move around, a certain amount of energy is suddenly released. That we see in the form of flares. Flares are a suddenly intense emission of electromagnetic radiation from the side of the sun, and it ranges from ultraviolet to X-rays and then gamma rays also, and also it releases very high energy charged particles. These charged particles are mostly electrons and protons. And of course, there are some helium nuclei also which are ionized. Now, all of this is sort of sent in any direction wherever out into space. And this time, for example, as I'm talking of that big sunspot, its designation is AR 3848. AR means active region. Active region means there is a very strong magnetic field there. Rest of the sun may have a one Gauss strength magnetic field, but these areas have hundreds of thousands of Gauss in terms of the magnetic field intensity. So there, whatever happens is all very remarkable, and in the sudden release of energy due to some instability, then a flare is produced, and in 8.3 minutes, that radiation reaches us. But high energy particles also emitted at a very high velocity, and they take a little more time while reaching the Earth. But when they come close to the Earth's magnetosphere, which extends in the direction of the sun about 10 Earth radii or so during daytime. So there, as they enter, so there is an interaction, and they because the Earth is also like a bar magnet, and it has poles, and although it's not exactly the geographical poles, but a few degrees away from there. So, like a bar magnet, they follow the magnetic field lines towards the poles. The path is curved. So, for example, it's a big cone, and assume that near this hand, it's towards the pole. So, as they follow the curved path, they radiate. So, at that time, as the charged particles follow these curved paths, they radiate, and then we see radiation in the atmosphere of the Earth in the form of auroral lights. Say Aurora Borealis, which is northern lights,
The northern
and
lights.
Aurora Australis, which is southern lights. And day before yesterday, also it was expected that because of such a storm-like situation, there will be effect on the Earth, and we'll see the atmosphere, the auroral lights also. And they have been seen in a large number of states in the U.S. And I have seen some images where there is a red light, which means it was a very strong flare, and because of that, much higher in the atmosphere, the oxygen molecules were impacted by the charged particles, and then the red radiation came out. Generally, it's green, or even it can be blue, which is at 100 to 300-kilometer height. So now, apart from this, a certain explosion of gaseous material also from the site of the flare. That we call coronal mass ejection. It's a huge blob of plasma that expands into space. So,
So it's a blast of energy, is it that?
yes, yes, it's blast of energy, but it's a blast that energy causes this blob of plasma to be lifted and then thrown into space. So the 6 October event was somewhat on the side, because by then the sunspot had moved, because of the rotation of the sun, had moved to the say western side. So it was literally that coronal mass ejection took place, but as it expands, so we got a little sort of effect of it also as it moved towards the Earth, that edge. But now this time, the sunspot I'm talking of is active region 3848. It's right now staring at us, and already if flare has taken place, which is a very high energy, and it has also lifted a very huge blob of plasma, and that is expanding out into space, and it is hoped that possibly tomorrow
That
we'll
is
get the
October
effect.
10th.
Yes,
Yeah.
October
So
10th. Yeah. And the effect that we are going to notice is
yeah.
the radio blackouts of short waves below 30 megahertz. And apart from that, more important is the effect on the satellites. You see, now it is we live a very highly technical life, and our communication is made possible by the satellites which are in the low Earth orbit around the Earth. And that apart, also geostationary satellites are there, which are at a much higher height above the surface of the sun. Oh, sorry, surface of the Earth. Now, what happens is that these charged particles penetrate the body of the satellite and generate DC currents, and that can short circuit certain things. So, when such a storm takes place and then a mass ejection takes place, so then we know that it's headed towards the Earth. So then we have to prepare ourselves. So when it's about to arrive at the site of the satellite, we switch off the satellite or we reorient it. But they also affect the International Space Station, where there are astronauts there. Now they are all constantly exposed to high energy radiation,
Yeah.
and the charged particles are all the time hitting the that space station. So they have to also safeguard themselves. So at that time, a certain reorientation takes place, and all of that is there. All precaution is to be taken, But directly on Earth, as we are living, it,
Hmm.
it doesn't seriously affect us because we are protected by the atmosphere and then the magnetic field of the Earth also.
So just to understand and clarify this, the effect is mostly usually when we have sun's flares, it's the northern lights and the southern lights that we see, and the effect that we are going to see with the sunstorm might probably be the satellites and telecommunication blockage that might happen for a while, and of
Yeah.
course it might affect the space stations and the
Yeah.
satellites, but nothing specifically to, let's say, humans or anything that we would directly get impacted with.
Hardly any, because we are on the surface of the Earth. Then there is the Earth's atmosphere to protect us. That apart, the magnetic field of the Earth as a bar magnet, most of the high energy particles are directed towards the poles.
Okay.
So whatever radiation they have given out in as they impact the oxygen molecules. So we see that in the form of beautiful northern lights. A lot of people go to higher latitudes, for example, places like Finland and other places in Europe, and they expect that there may be these
Northern,
auroral
yeah.
displays. Right now, my own family members are in Finland and expecting auroral lights, but they say that there are right now clouds there, and I also alerted them that there is a huge sunspot staring at the Earth, and a coronal mass ejection has taken place. So hope possibly tomorrow that you might get to see these lights.
Also, as far as I think I know, there we can see the northern lights in high up in Ladakh as somewhere that as well. Do you expect that we will be able to see it in India as well in that region, in the higher altitudes?
It's possible because this time, because it's a very strong, high energy X-ray flare that has been emitted. So, because Ladakh is close to about 30 degrees latitude, and in, for example, Texas also they have seen, Arizona also they have seen the northern lights. That means that there is a very huge and very big coronal mass ejection that has taken place, so that the effect has reached even lower latitudes, which is why some time ago in Ladakh the northern lights were seen, and very beautiful pictures were presented on the X,
Yeah.
the Twitter. Yeah, so I'm hoping that this time also there may be something.
Okay, so there are chances. I'm sure that
Yes,
everybody would be excited to look at that.
yes.
Also, if you could tell us how one thing that we would want to know definitely is what causes it. What's exactly causing the solar storms? Is it just the burst of energy, the higher radiations, or is it something else that changes over a period of time and it causes it?
Actually, see, a lot of research has taken place in the whatever activities take place in terms of the interaction between plasma and the magnetic field of the sun. And each day some new thing is found out, and then we always find ourselves at the seashore only. Although we say that we know a lot, and then we say that we hardly know anything. So some of these processes are very complicated and not really well understood. So what is in a few words is to be said is that certain instabilities are there which we do not know their nature. So, but something happens. So it's an interaction between plasma and magnetic field. There's a lot of energy that gets stored in these twisted magnetic fields, and then sudden burst takes place. We see that release in the form of high energy radiation and high energy particles that are ejected from the side of the sun. So that end effect we are seeing, but what exactly is the cause behind this? A lot of mathematics we work with, and still we find ourselves that perhaps we know not so
Very
much.
little. Yeah. Also, one last thing that we would like to ask is ISRO has mentioned that they are preparing for the blockades in case if it happens in India. There are precautions taking place. Is that enough? What do you have to say about it?
See, one thing is that because when such a event takes place, like yesterday it has taken place, and we are expecting. One thing is that when they get an idea that this that particles are approaching the Earth, that huge blob of plasma, which has sort of basically it has thinned out. Still, there is a lot of material that is being dumped into the ionosphere of the Earth. So then we prepare ourselves that in terms of either switching off the satellites for some time, because a storm may last for about 4 hours or so. So, but as it travels through space towards the Earth, and as it reaches the Earth, then we have to know that how long is it going to last. It may last several hours also. So that is one thing. And that apart, there are transmission companies, power transmission companies. For example, there was an event in 1989.
Mhm.
There was power outage in Quebec, in Canada. That was attributed to a huge storm
Storm, yeah.
that had come towards the Earth, and then because of the power outage for 9 to 12 hours, it had taken place. So now they are well ready, because either they will switch off, or then they make arrangements in such a way that these transformers and power generating units are not affected. So that is another thing. Besides, for instance, our satellites are there, so there are a lot of assets in space, and they have to remain protected. Now, there is one more thing I want to tell you is that,
Yeah.
see, there is a SOHO in space. It's a solar heliospheric observatory that NASA's and ESA's. It was launched in 1995, and it is at a place called Lagrange 1. Lagrange 1 is a point you would have heard about, read about last year and early this year also. It's a point at which roughly the gravitational field force of the Earth and gravitational force of the Sun nearly equalize. So it's a point where both the forces balance. We call there is certain mathematical solution to this orbital problem, the orbit as the Earth orbits the Sun. So that is called Lagrange 1 point. It's between the Earth and the Sun, and it's about 15 lakh kilometers from us towards the Sun. That is called L1. So SOHO is located there. So it once the coronal mass ejection particles are passing that point, so the SOHO's instruments detect that. So it gives us about half an hour lead time of alert, so that we can take care of the satellites, how to reorient them and how to reorient the International Space Station. Now there is another space station also there. It's Space Observatory of India. It's called Aditya L1.
Hmm.
Aditya was launched, as you remember, last year, and then it was placed in a orbit around that L1 point
Yeah.
early January this year. So this also is aimed from that point of view also, because instruments on it are active, and they also detect the high energy particles that form as it passes through that L1 point. So, Indian laboratories, Indian scientists are also able to get that advanced alert. So, half an hour lead time is real good. See, for example, in the matter of the X-ray flare, it travels at the speed of light, radiation. In the matter of the coronal mass ejection, those high energy particles, they are slower. So their speeds can be, that plasma blob speed can be 200 kilometers to 3000 kilometers per second. So it takes its own time. It can reach us in 25 hours from the sun, or 48 hours from there. So once we have seen a solar flare, then already there is an alert. So once the instruments on SOHO and Aditya L1, they send the signals, then we know that it's coming. So that time is good enough for us to take precautions and then work on.
So ISRO might already be aware in case if it's coming, they will get the precaution, they will get the time to switch off the satellites and have other precautions in place already.
Yes. So certainly yes, because you know that once the coronal mass ejection hits the ionosphere of the Earth, it dumps a lot of charged particles into the atmosphere.
Atmosphere, yeah.
That atmosphere gets slightly heated up and it expands. As it expands, there is an atmosphere drag on the low Earth orbits. So those orbits which are say 400 to 1,000 kilometers above the ground. So there is a slightly increased density of the atmosphere. It tends to slow down the satellite, and that satellite tends to fall. So its orbit is slightly reduced. So then we have to use the thrusters to raise the orbit back to its
Yeah,
original position. Otherwise, the
that
satellite
will be damaged.
life will be reduced. So that precaution we have to take. So each satellite has certain amount of fuel to face this kind of eventuality.
Also, do you expect that because Aditya L1 is there, will we be able to gather some data and, of course, have some more research into this phenomenon, get some more information about this through it? Is it possible?
Certainly, yes, because there are instruments on the satellites and on the laboratories that are there in space. So, as the storm passes by, so their instruments are already active and they detect the enhanced charge particle emission, and that is recorded. And then we also see how on the in terms of passage of time, how the intensity comes down, and then how gradually it falls off. So then we know at what level we can say that the storm has virtually passed that point. So that's how it is. So each event, whether it's a small scale event or a large scale event, it is sort of being detected, and then we'll also know. See, for example, in certain events, the effect was noticed at the orbit of Mars, Jupiter, Saturn. Also, even Voyagers have detected those enhanced emissions of charged particles. So you can see that how sensitive the instruments are on board on of these space observatory.
L1, yeah.
Uh,
Right. Thank you so much, sir. It's very interesting. Definitely, everybody will be looking forward to seeing the Northern Lights here at least. Thank
Certainly yes, certainly yes, and let's see how the pictures are, because a lot of people post them on the social media.
yeah,
So I'm hoping.
yeah. Thank you so much, sir.
Okay, welcome.